Okay.
I'll be here.
Sounds good, because we'll need to get that done.
Yeah. I think on shows and such, and I'll be on
It adds up.
for a while though.
Well, that's good. If there's no questions over the homework, all the note sheets are in that first pile.
And you gave us a worksheet.
Yep. Which will be in that pile or on Google Classroom. Because all the worksheets, I do put a PDF version of it in Google Classroom for y'all to use. You can have both. Now, completing the square. This here is so Laren, this is the first method that works for all of them. Because up to this point, we've done graphing, which worked well, as long as it crossed the x-axis. If it didn't cross the x-axis, we couldn't find it. And if it didn't cross at nice numbers, if it was square root of 3, negative square root of 3, we could find it by graphing, but we would really need to know what the decimal approximation of the square root of 3 or what it looked like to get that. Factoring worked well if we had nice integers or rational numbers, because if we got radical answers, it didn't work. If we got complex answers, which is I, which we did in 3-4, which is the square root of -1, we can't get it that way. So this is the first method that works for any and all quadratics. It works without fail. Now the first step is A equal to 1? If not, make it so. Is A equal to 1? If not, make it so. Step 2, get the constant term by itself. And leave 2 spaces. Our third step is to find C, which is our B over 2 squared, then plug in. And the last step is to factor and solve. Factor and solve. Bless you. Someone's talking about you. Yeah, that's the, if you sneeze. If you get goosebumps or chills, someone walked over your grave. Yep. Yep. So 3, find C, then plug in, and last we're going to factor and solve. So these are the main 4 steps for completing the square. Now we're going to start off with the second one because we did the first one yesterday. All right, guys. So looking at this here, the main thing we want to do is if we can rewrite this as a perfect square trinomial, that's the goal. So that we can rewrite it as a set of parentheses squared. Well, is 9 a perfect square?
Yes.
Mm-hmm.
Wait, where are we at?
The second one. So we could see here if we could factor this so it's the same set of parentheses. Since the 9 is positive, the signs are the same and they match the sign of the middle term, which would be negative, and the factors of x squared are x and x. And the factors of 9 that we want is 3 and 3. So this actually works out to be x minus 3 squared. So this is a perfect square trinomial to begin with. Since we have it as a set of parentheses squared, we can square root both sides. Well, the square root and square would cancel.
So what are you marking out on that?
The square root. Because the square root of something being squared simplifies out, leaving us with minus 3 equals square root of 1.
What times 1 is 1?
So, because again, the square root of 1 is 1, because 1 times 1 is 1. It actually works out any root of 1 that we take, so the cubed root of 1 or the fourth root of 1 is still 1.
Can we play another one of those games
We'll see if it has it. Well, the next thing we need to do is add 3 to both sides to get x by itself. So we get x is equal to 3 plus or minus 1. Now, if we can simplify, we're going to. Because if we can add 3 and 1 or subtract 3 and 1, we're going to need 2. Yep. Because 3 plus 1 is?
4.
And x is also equal to 3 minus 1. Because if we can add the 2 together and subtract them, we're going to need 2. Which is really just telling us x is equal to 4 comma 2. Similar, yes. I would at least need the yellow one. Questions on any of this here so far?
So then for the homework, we need to have the perfect square and the answer.
Yeah, well, for this here, we're just solving. So we have this here. Now, it says check your solutions, which would just be 4 squared minus 6 times 4 plus 9 is equal to 1. Well, 4 squared is 16. Minus 24 plus 9 is equal to 1. 16 minus 24 is negative 8. And negative 8 plus 9 is 1. So that works. We can do the same with 2. 2 squared minus 6 times 2 plus 9 is equal to 1. Well, 2 squared is 4. Minus 12 plus 9 is 1. 4 minus 12 is negative 8. Negative 8 plus 9 is 1. So it works out.
Or number 7.
So for number 7, now on the last one, the reason we check to see if it's a perfect square is if we could rewrite it as a set of parentheses squared, yes? What number times itself is 8? Is there one? No. There technically is one. It's 2 square root of 2. So 2 square root of 2 squared. 2 squared is 4. Square root of 2 squared is 2. 4 times 2 is 8. But there's not a nice number that works out for that. So we're going to use and do completing the square. So we're going to complete the square. Yes. Because x squared minus 6x plus 9 is a perfect square trinomial. Yep.
Oh, so we had to make the 0 equal 1.
So the first one is a equal to 1. Yeah, because a, again, is in reference to our ax squared plus bx plus, so a is 1, because the number in front of x squared is 1. So, okay, so we have that for part 1, step 1. So we're good. Step 2, get the constant terms by itself. So here we would need to subtract 8 from both sides, which will tell us that we have x squared minus 4x, and it also says to leave 2 spaces. We have this here. Because the key part with completing the square method, is that we are wanting to make a perfect square trinomial. And a perfect square trinomial can be rewritten as a set of parentheses squared. Because if I can rewrite it in such a way that we get a set of parentheses squared, we can then take the square root of both sides and solve. That's the whole goal with the completing the square method. So any questions on this so far? Okay, so that takes care of step 2. We've got the constant terms, the terms without a variable by themselves, yes? Now, we need to find c. That's the third step. And c is equal to b over 2 squared. C is equal to b over 2 squared. Now, for us here, the value of b is what? Yes, almost. It would be negative. We need the sign with it. We need to take the sign with it. Since it's minus 4x, b is negative 4. Now the next thing we need to do is simplify this here. So negative 4 divided by 2 is negative 2 squared. And negative 2 times negative 2 is 4. Now we plug it into both of those spots. Because if we add something to one side, we have to add it to the other. So when you factor x squared minus 4x plus 4, the first term is going to be x. Now we could go through the steps we did on the last one, 2 sets of parentheses, and the factors going that way here. But it works out that whatever's in the parentheses before we square it is what's going to go in there. So here it's going to be minus 2. And we have negative 8 plus 4 is negative 4. Any questions on this here? We good so far, Larry? Not confusing you too bad? Okay. Now the next thing we need to do is simplify this. Now we can do that by taking the square root of both sides. Because the square root of that parentheses squared, well, the square root and square will cancel, leaving us with x minus 2 is equal to plus or minus. Because whenever we take the square root of both sides, we have to add the plus or minus on one side. Now, we need to take the square root of negative 4. Now, so Lauren, you weren't here for this day. I is the square root of negative 1. I is the square root of negative 1. It's just by definition that there. Now, whenever we have the square root of a negative, one thing we know for certain is that this negative is going to come out as I, which leaves us with the square root of, we can simplify the square root of 4. This is also where the yellow calculators or the white one that you have work nicely, because it'll simplify it in radical form. But the last step is to get x by itself. Now for us here, that's the answer. Because I, as we said, is the square root of negative 1. Well, 2 times the square root of negative 1 and 2, those aren't like terms. They don't have that same radical, so we can't technically add them. So that's our answer. Questions on any of this here? Are you ready for the next one? X squared plus 8x minus 5 is a equal to 1. Yeah, number in front of x squared 1, yes. Step 2, get the constant terms by themselves. And leave 2 spaces. So x squared plus 8x plus blank equals 5 plus blank. Now we can write plus in both spots because we know c is always going to be positive. Because what is it? It's b over 2 squared. Anytime we square a number, it's always going to come out positive. So here c is equal to b over 2 squared. Well, our value of b in this case is 8 divided by 2 is, and 4 squared is. So we're adding 16 to both sides. And what goes inside the parentheses with x is whatever we have before we squared it. So it's positive 4, which means this is plus 4. 5 plus 16 is 21. So we did part of step 4. We factored it, yes? And the last part is to solve. So we would square root both sides. And the square root and square will cancel, telling us x plus 4 is equal to plus or minus the square root of 21. What can we do next? Minus 4. X is equal to negative 4 plus or minus the square root of 21. And that's it. Because if we have to approximate the radical, it doesn't come out to a number when we plug it in. Leave it as this here. The only time that we would need to turn it into a decimal is if the question itself asked you to approximate the values or the solutions, then we would need to turn it to a decimal. Otherwise, this here works just fine. Questions on this here? Now, on a side note, really what the plus and minus is saying is that x is equal to negative 4 plus the square root of 21, and x is equal to negative 4 minus the square root of 21, yes? Now, one of the formulas or kind of theorems we had the other day, actually literally Tuesday, was the complex conjugate formula, or complex conjugate theorem. And what that stated was that if a plus bi is a solution, then a minus bi is a solution. We have to have the positive and negative case for I. There is also something called the irrational conjugates theorem. The irrational conjugates theorem, which really just states that if a plus the square root of b is a solution, then a minus the square root of b is a solution. We have to have the conjugates with radicals as well. And we have it here. We have a plus the square root and a minus the square root. If we have one, we have to have the other. Which seems okay, what does that mean? Especially, it's helpful on the ACT, because when they give you solutions for the equations and you got 5 to pick from, and they normally list them both out, they don't have the plus or minus. If they give you positive version with a square root, you have to have the negative also. If you have one, you have to have the other. All right. Let's look at the next one, because we only have 3 left here on the note sheet. Yes? Okay. Is A equal to 1? What is A? 3. So if not, make it so. So how can I turn 3x squared into just x squared? If we divide one of them by 3, we have to divide them all by 3. 3x squared divided by 3 is plus. Well, 0/3 is 0. Okay. We finished that there, yes? Step 2, get the constant term by itself. So really we're getting all the numbers without a variable on one side and all the variables on the, yes. Yeah. You can go on and pull that door. So we have this here when we subtracted 5 from both sides. So that takes us through steps 1 and 2, yes? Now C is equal to the square root of both sides. When we take the square root of both sides, we add the plus or minus. Because what we're saying is x squared is equal to 9, yes? So what we're asking at this point, kind of this is a side note, is what number times itself is 9? That's really what the question is when we have this part. And we know when we square root both sides, so when we square root x squared, the square root and square will cancel each other out. So we get x is equal to, well, the square root of 9 is 3, because 3 times 3 is 9, yes? And for geometry, and a lot of the times we brought this up in geometry, we said that was it, really gave no explanation, just said it's 3. But what is negative 3 times negative 3? It's 9 also. A negative times a negative is a. So anytime we take the square root of both sides, we add the plus or minus. Yeah, now for geometry, the reason we always said, okay, square root of both sides, square root of 9 is 3, and then left it, is because most of the cases for those there, we were talking about a length. We're talking about a side length or the radius of a circle. And any distance is always positive. So normally we just say it's positive 3 and move on. We don't mention the negative case. But it is still plus and minus even in that case. We just throw the negative out because it doesn't work in that problem. Okay. Now what's the value of b? So here we have positive 4 over 2 squared. X plus. Yep, so what's inside the, with x is going to be our plus 2. And we get this here. Now what can we do? Yeah. Now, again, we can do the same thing we've been doing on the rest of them. We can pull the negative out as I, which leaves us with what? The square root of 1, which is 1. So we have 1i, but we don't have to write the 1 because it's understood. We can just leave it as I. Yeah. And last but not least, we would x plus or minus I. Because I and 2 are not like terms, because I is considered the imaginary part, negative 2 is the real part, we would leave it as this here. Questions on any of these here? Do we feel comfortable with this here? What would we divide for this one? Almost. Negative 3. Because we need a to be a positive 1. But that would be the only thing for that there. I'm going to go on and run through this because I feel like y'all feel comfortable with this, so I'm going to do it a little bit faster than we were doing the last one. So we would divide everything by negative 3, which will tell us that we have x squared plus 6x plus 2 is equal to 0. What? Yes. So then we would subtract the 2 and leave 2 spaces. Now we find the value of c. C is equal to b over 2 squared, which would be 6 over 2. 6 divided by 2 is 3. 3 squared is 9. So we would have 9 and 9. Now this here would factor 2 plus 3 squared is equal to, then we would square root both sides, telling us that x plus 3 plus or minus the square root of 7 minus 3 from both sides, telling us x is equal to negative 3 plus or minus the square root of. So it's the same thing, except the first step we had to divide by 3 instead of a positive number. It still works out the exact same. And that's the nice thing about completing the squares. No matter the setup or what the numbers are, we can still use this to find out what it is. Now, number 10, we have 4x squared plus 32x is equal to negative 68. Yeah.
How would we add 68?
Oh, I got it right.
What's step number 2? Get the constant term by itself. So the number without the variable by itself, yes? Is it already by itself? Yeah, it's already over there. The only reason we would want to move it back over is if we were going to graph it, factor it, actually do our 2 sets of parentheses and solve from there, or the quadratic formula, which is tomorrow, are the 3 cases we really need this equal to 0. If we're solving by the square root method, we didn't have a middle term, we need to get the constant term over there anyways. If we're doing completing the square, we're going to need to get it over there eventually anyways. So for this here, it's not a big deal that it's already on the other side. Now, if there was plus 10x, we would need to get the 10x over to the other side. But yes, our first step is we can divide everything by 4 because a is not 1. Because 4x squared divided by 4 is x squared. Plus 32 divided by 4 is 8x plus blank is equal to, so we can go on and add our spaces in. Now we need to find c, which is our b over 2 squared. And what is b? 8 divided by 2 is? Set of parentheses squared. So we would have x 4 equals negative 1, because negative 17 plus 16 is negative 1. Then we would, both of those would cancel, telling me x plus 4 is equal to plus or minus I, minus 4 from both sides, telling us x is equal to negative 4 plus or minus I. Questions on this here? Here's the next one. Yeah, I want y'all to watch this one because it's not any different than what we're doing. It's just a little bit different, but the method's still the same. Because again, the first step is a equal to 1. So we need to divide everything by 2. 2x squared divided by 2 is? Does 5 divide by 2 evenly? If we can simplify it, we're going to simplify it. But we're not going to turn it into a decimal.
Minus 6.
Which will tell us that x squared minus half x plus blank equals negative 67 over 2 plus blank. Because we still need to find c for this here. Now c is our b value over 2 squared. Well, our b value is negative 5 over 2 over 2. Now, we don't have to do that by hand because the calculator will do it just fine. Over 4. Because it sees it as what the calculator saw there was negative 5 over. Because if you type this in, you'll hit the fraction. In the top, you'll hit the fraction again to do negative 5 halves over 2. Negative 5 over 4. If we square this, well, we know what's going to come out as a positive. 5 squared, 5 times 5 is 25, and 4 squared is 16. If you don't put the parentheses around it, yep. And again, one thing that's nice to remember is that any time the value of c that we get has to be positive. So if we get a negative, it's just we need to put parentheses around it. And we can plug it back in here.
So you just do the same thing, but with the fractions there. And then see all the rest of the
Yes. Now, inside our parentheses squared, we'll still have x minus, because what we had before we squared it was negative 5/4. So that's what goes inside the parentheses. Now, we still need to simplify the other side, negative 67 halves plus 25 sixteenths, negative 511 over 16. I've done this problem twice today already. This is the third time around, so. Well, I at least remember the numerator.
You also done it like
Wait, yeah.
4 years.
Add 3 more years to that. Yeah, this is number 8, so. Yeah. So, we're going to cancel those 2 out. I can bump it down one more. Yep. Which will tell us that this is x minus 5/4 is equal to plus or minus. We know the negative is going to come out as I. Square root of 511 is still just the square root of 511. There is no perfect square factor that can simplify it. What's the square root of 16? Because we don't want a radical in the bottom of the fraction. So for this one here in the yellow calculator, you can do the square root of 511 over the square root of 16. You want to break that into 2 and let it do it for you. But the last thing is we have to add 5/4 to both sides, which tells us x is equal to 5/4 plus or minus the square root of 511 over 4i. And this would be our final answer. Now we could, because they do have the same denominator, rewrite it as 5 plus or minus I square root of 511 over 4. Those are the same answer. It's just one of them's written as a single fraction, the other's written as 2. But that's it.